All right, everyone. So, as Sid mentioned, I'm going to cover the PowerShell Core specifically on the web commandlets, which is Invoke-RestMethod and Invoke-WebRequest, two commandlets that have been pretty heavily used more recently in PowerShell. And they are more radically different than a lot of other pieces of PowerShell Core between Windows PowerShell 5.1 and PowerShell Core 6.0. So that's what I'm going to focus on here. So first of all, who am I? I'm Mark Kraus. I'm a lead IT solutions architect for Mitel. I'm a collaborator on the PowerShell project, so the open source PowerShell Core project. I'm a collaborator for that. I'm a contributor primarily for the web commandlets, but I've also done some work for some of the other commandlets and a lot of work for the test as well. I'm the author of the Get PowerShell blog, covers some intermediate to advanced level PowerShell topics in PowerShell Core. And very recently I was awarded a Microsoft MVP in the data center and cloud management area. So the four main topics I'm going to cover is just a brief overview of PowerShell Core and the RC2 release, the move in the web commandlets from WebRequest to HTTP client, which is an underlying architecture change, and then some of the deprecated and or missing features and open issues in PowerShell Core's web commandlets, as well as all the new features and fixes, all the goodies that are available in them. So first of all, we kind of already covered it, but PowerShell Core is cross-platform. It's on Mac and Linux and even Raspberry Pi they've got it running on, and they're working on getting on as many platforms as possible. Can, in theory, run on anything that .NET Core can run on, which is a very wide variety of platforms and OSs. Release Candidate 2 was put out on 12/14, so GA. Release, so the actual final 6.00 is set for January 10th, so very, very soon, lots going on there. So what you can do right now, though, is you can go and install the Release Candidate 2, run all your scripts that you run in Windows PowerShell and see what does and doesn't work. Find out if there's any open issues or whatever. And unlike with previous versions of PowerShell, with Windows PowerShell, there's a lot more community involvement with the PowerShell Core. So people like me who aren't Microsoft employees are actively working on issues that you open up in the PowerShell repo, and there's been a lot of community involvement, lots of fixes, lots of new features done by community members that aren't Microsoft employees in PowerShell Core. So unlike user voice, where it was kind of like the dev null of complaints, it's actually being monitored and used, and there's some accountability there because the community is actually involved.
Hey, Mark.
Yes.
Are you using like the GitHub when you submit your any issues?
Yeah. So on the GitHub here, the PowerShell GitHub, on the issues thing, this is where you can come and actually just open up a new issue after you'd sign in. But do you see there's quite a few open already? There's
Can you make it a little bigger?
I don't know how. Sorry, not really used to that.
That's all right.
So yeah, that's kind of where you just go to do that, and we've got a lot open, and they're actively worked by both community members and Microsoft employees.
We were wanting to do something with that later, you know, just to get used to working in the Git environment. So maybe I'll talk to you about that offline.
All right. So one of the biggest changes about Invoke-WebRequest and Invoke-RestMethod in PowerShell Core from Windows PowerShell is that the underlying .NET APIs that they use are completely different, and this is a little bit outside of the normal comfort zone for most PowerShell users, but I'm going to talk about how these bubble up into your actual PowerShell user experience as well. But just kind of overview of the architecture change so that you can kind of understand why it looks different to you as a PowerShell user. So in Windows PowerShell 5.1, the web commandlets used the web request. It's system.net web request. And it used that to make all of its web calls. This is a slightly older API. It was introduced in .NET 2.0. It's slightly less performant in .NET Core because HTTP client, which is what Core has moved to, is a bigger focus. It's a newer API. So they've been doing a lot more optimization there. It has a slightly less attractive asynchronization usage. It uses the older async calls in .NET. Not that that really matters a lot because PowerShell calls these APIs synchronously, but it did kind of limit what could be done in the past. And WebRequest also supported a lot of protocols. It was more generic. It was created before the internet was really just HTTP and HTTPS. So it supports more things that you could do on the internet, more general. HTTP client is what has been moved to in PowerShell Core, and this is system.net.http.http client. It acts more like a headless web browser, which makes it a better fit for the web commandlets, which are used more like a web browser and less like a general web utility, especially with the way that the web commandlets work. It has the more attractive, more modern async usage in .NET, which means that we can do more with it and actually look at some of those async usages now within it. Opens up more possibilities to us. It does only support HTTP and HTTPS, so it's a pure HTTP and HTTPS client, which is great because then it's optimized for those and doesn't have to work with all these other protocols, which makes it more performant, makes it a bit easier to work with. It also allows for greater reuse. The web commandlets currently aren't designed to reuse the HTTP client, but in the future it could be done, and that would mean faster calls for you, less memory overhead, all that good stuff that would come out of that. But it comes with some side effects to that change. It wasn't like a one-to-one change. So one of the first things that you might run into is if you've ever used the headers or the user agent parameters on either Invoke-WebRequest or Invoke-RestMethod. The HTTP client API in .NET Core that the web commandlets use is by default doing strict request header parsing. So if you use an RFC-defined header in your request to the web server, HTTP client is checking to make sure that you're using an RFC compliant value with that by default. So we've added the skip header validation parameter to both commandlets to allow you to bypass this behavior. And that was done in pull requests 4085 and 4479. And just kind of show what that looks like is the if match is an RFC-defined request header. And 12345 is not an RFC-compliant value. So Windows 5.1, PowerShell 5.1, you could run this and it would work without any kind of complaints. However, in 6.0, you're going to get this Invoke-RestMethod. The format of value 12345 is invalid. And that's because it's just not an RFC-compliant value, and strict header validation is default. So you can pass it then, the skip header validation, which it's a switch, but I'm using @splatting here instead of named parameters. So you would pass the skip header validation to it, and it would go through without any errors. So for some backwards compatibility or forwards compatibility, whichever we want to look at it, you can put in your scripts, if you were using headers, any kind of specialty headers in your code, you can use the PS default parameters values automatic variable to set the skip headers validation to true for both Invoke-WebRequest and Invoke-RestMethod. And you can do this on both 6.00 and 5.1, because on 5.1, if that's the way that the default PS default parameter values works, is if the parameter is not available, it just ignores that you've set that. So it just doesn't do anything on 5.1. And on 6.0, it turns off the default validation behavior. So the next kind of bubble up is that the HTTP client API returns a different type of object than the web request API did. So this is kind of not seen to you most of the time unless you're doing some more advanced access with the objects returned from Invoke-WebRequest and Invoke-RestMethod, but it can show itself a little bit here. If you've ever used the base response property on, if you did Invoke-WebRequest to, say, google.com, and you looked at the object that it returns, the base response property on that would have been an HTTP web response in Windows PowerShell 5.1. And in PowerShell Core 6.00, it is HTTP response message. They look very similar, but things are in different places, and some of the value types of some of those parameter properties on that object are definitely different. And a lot of the methods on those objects are completely different. So just kind of be aware of that. If you're doing anything on base response, some of your code from 5.1 is going to definitely break in 6.00. The most apparent one to most users that have done anything is the headers. So the response headers that you get back from the web server, be anything like date or content type or anything like that. Those were in Windows PowerShell 5.1. There's a headers property on the response object from Invoke-WebRequest. And it's kind of like a hash table that has like the key is the header name and the value is the header value. And they were strings, so it was a string key and a string value. Well, since the type of header collection has changed from web header collection to HTTP headers as a result of this, the types of values have changed as well. In PowerShell 5.1, it is a string, but in 6.00 it is a string array, which is going to cause some difficulties if you're doing anything with that headers property. And the other thing about the headers is that the content-related headers are now separated out from the headers. Now, this only happens under the base response object, which is what's returned directly from the .NET API, but it is something that if you're digging around in that the content headers are going to be in a separate space. Now, in the actual like headers on what you see on Invoke-WebRequest, what's returned, we're actually reconstituting that for you, so you don't have to worry about it there. So it's only on the base response. But the content now lives under a content property, and then the headers underneath that. So the headers like content-type, where you would look to see if it's a JSON response or HTML or XML, something like that. That's going to be in a different space underneath the base response object. And this also changes the error handling that was done with Windows PowerShell 5.1. It was a common practice that if you are accessing an API and you're writing a piece of code to wrap it, you create like your own wrapper for Invoke-WebRequest or Invoke-RestMethod, and you would then do some checking on it. You would do error action stop and then put it in a try catch, and then in the catch you would inspect the exception that's returned, and that way you can get like the error messages from the server. So since the response object has changed, then that also changes the response object on the exception as well. So you can see here that just demoing that they're in 5.1 it would be the HTTP web response, but in 6.0 it's an HTTP response message.
I've got a question.
Sure.
Now, with the majority of the changes that they have here between 6.00 and 5.1, have they already updated MSDN with a lot of the new features that are within this new PowerShell Core?
So yes, well, yes and no. So the MSDN documentation is being completely removed. Most of it's on docs.microsoft.com, but for the 6.00 for the web commandlets pieces, a lot of that has been updated and documented. So if you go to docs.microsoft.com and look at the PowerShell piece and go to the reference, you can see all of the stuff there. Now, there are actual .NET APIs for the PowerShell pieces. That still has to be updated. I think they're waiting for a release to update that. And then also, since this is .NET Core instead of .NET Framework, if you're going to look at the raw .NET objects, they're going to be under .NET Core 2.0 as opposed to .NET Framework 4.6 or whatever. So when you're looking at docs.microsoft.com, just kind of keep that in mind. So here's just kind of a demonstration of some of the differences between 5.1 and 6.0. So basically just making an invoke web request to google.com and looking at the headers, looking at the base response, and looking at the base response headers, and then looking to see if the base response.content.headers is there. And on 5.1, you'll see that a header value is a string, that the response object is an HTTP web response, that the headers collection is a web headers collection, and that there is no content.headers, whereas on 6.00, a headers value is going to be a string array, the base response is an HTTP response message, and the headers is an HTTP response headers, and there is a content.headers property. So just kind of how it looks slightly different between the two. We get slightly different results. So you'll want to watch out for that headers being an array. It can throw you for a loop. It definitely threw me for a loop when I first started porting some code to 6.00. One of the things that you'll run into is you might have a strongly typed variable, or it might be a property on some kind of .NET class, and you're trying to assign one of these headers to it. And in PowerShell, it automatically transforms strings into integers for you, but it doesn't do that for string arrays. So since in PowerShell 5.1 it was just a single string in the headers collection, it would automatically return convert the expires, which often gives -1 to mean that it needs to be refreshed every single time you access it. The expires would automatically convert that string of -1 into the integer -1, and everyone would be happy. But in PowerShell Core, since it's a string array, you can't automatically convert a string array into an integer. So if you try to do the same thing, you're going to see this lovely cannot convert string array to string array of type system int 32. So to get around that, you got a couple of options for some compatibility. So these options will work on either 5.1 or 6.0. The first one is to join the headers with a comma. So if it's a single string and you run a join operation on a single string, it doesn't do anything. So it just keeps the original string. And if it's an array, it joins it together with the comma. So if it's a single item in the array, it doesn't do anything with that comma, it just returns a single array. So this is kind of a cheap way of cheating to make 5.1 and 6.0 act exactly the same. And in 5.1, WebRequest is kind of actually doing this in the background anyways. There's an issue, there's a a way that a web server will return the same header. So it'll return expires multiple times with multiple values, and that's why it would be an array. But Windows PowerShell 5.1, since it was using WebRequest, WebRequest kind of smashes all those together into a single string concatenated with a comma anyways. So this will make your this top option here of doing the join with the comma, that'll make your headers look in 6.0 like they did in 5.1. But another option is that if you know you're working with a single value, like expires is almost always single value. It never has multiple. So if you know you're doing that, you can always use select object and get the first one. But what you shouldn't do is you shouldn't use the index access operator, you know, bracket 0 bracket, and try to cheat and get the first one there. And if you're familiar with strings and how they work in PowerShell, and if you put an index accessor on a string, it blows that string up into a char array and then returns the index of that char array. So in the case of the string -1, if you do the index accessor on that string, you're going to get the char value of -1. And if you sign that, the char value of the negative sign, or the dash minus, which, you know, you can then turn a char into an integer, which is the value of 45. So in 5.1, if you were to do this, you would get a weird thing where it says 45 instead of -1. So just be careful of trying to cheat using the index accessor. So that's kind of the architecture stuff. That should be the end of most of the .NET heavy pieces of it. So we'll actually get to more of the PowerShell related things. But this is kind of the sad part. This is the stuff that's missing or broken currently in PowerShell Core. So the first big one is that Invoke-WebRequest and Invoke-RestMethod don't have FTP or file supports. That's kind of sad, but that's because HTTP client only supports HTTP and HTTPS. So it's kind of temporary. What I'm looking at is creating an invoke download command and having it added there, and it'll be kind of a generalized download command. If any of you have ever used Linux, you're probably familiar with wget. And wget is really simple for downloading files. I mean, it's wget and then the URL, and it puts the file right in your folder. You don't have to like give a path or anything like that. And I think that kind of feature is missing from PowerShell. And it's not something that we can really do with the web commandlets, because Invoke-RestMethod and Invoke-WebRequest are kind of built for dealing with content after it's been given from the server, not necessarily with downloading files. So I think that we're missing an invoke download command, and that's something that I've been working on now. And ultimately, that would replace the FTP downloading and file downloading. Another thing that we're looking at possibly doing for FTP is adding a PS provider for it. So if you want to do more advanced FTP management, like uploading and downloading and renaming files and all the things you can do with FTP, we might be adding an FTP PS provider into PowerShell that could then be plugged in. You can connect to an FTP server and then manage it with commands like get child item and new item and remove item, all those kinds of PS provider commands. And I'm kind of tracking that under issue 5491 on the repo. The next thing that's kind of sad, and probably the biggest gripe that some people have, is that PowerShell Core's web commandlets and Invoke-WebRequest is going to be basic parsing only. And that's because in Windows PowerShell 5.1, HTML parsing depended on Internet Explorer and its COM interface. And that's definitely not available on Linux or Mac OS. Therefore, it's not available in .NET Core. So then it's not available in PowerShell Core as a result. So if you've ever used the parsed HTML property on the object returned from Invoke-WebRequest to do searching on HTML pages for things like find this div that has this ID and then get the text and do things with forms, that's just not available. And The future for that, though, is that we're looking at adding a convert from HTML commandlet. So this would be the opposite of convert to HTML, which takes a PowerShell object and makes an HTML page out of it. This will take HTML and turn it into a PowerShell object or a .NET object, but something you can use in PowerShell to then search and manage the HTML instead of having to do a whole bunch of text parsing. And that'll use AngleSharp, which is an open source project. We were originally hoping to get that added in 6.1, but it's not my project, and it's kind of above my skill level to implement. So the other community collaborator, Ilya, was working on that, and I think that he's a little too busy to get that done for 6.1, so it might be closer to 6.2 that gets available. So if you're doing HTML parsing and web scraping and all of that, you'll want to stick to Windows PowerShell for now. So just to kind of show some of the things that are missing from basic parsing being gone, in Windows PowerShell 5.1, you'd have to use the use basic parsing parameter to skip all that fancy parsing. But that's just default in PowerShell Core. So what I'm showing here is just going to google.com with Invoke-WebRequest, and without using the use basic parsing parameter, it's returning a basic HTML response object. So the things that are missing then is the forms property and the parsed HTML property. Links and images are still there. We're still going through and grabbing those and parsing those and making those available. And we also added another one which is revolving around the link header for rel links. So there's some more things that are there, but the nice parsed HTML object is not there. So another thing is that the new web service proxy command is not in PowerShell Core. This isn't technically a web commandlet. It was actually separate. It's in a completely different PowerShell module. It doesn't share the same code base. But I'm including it because some people just consider it a web commandlet. It's dependent on system.web.services DLL, which Microsoft has said they're not going to be porting anything from system.web with very few exceptions. So all the massive amounts of classes and objects underneath system.web are not going to be available on Core. And as a result, then we can't use the web service proxy command in PowerShell Core. I did look at the possibility of adding this. Now, what this command does is it works with SOAP, which is kind of a dying technology. REST is very rapidly replacing SOAP, and I haven't seen any new SOAP implementations in a long time, so it's probably not going to be a pain point for many people unless you're working with a lot of older technologies that still use SOAP. It's a low priority for the Microsoft team. They just don't have a lot of customers saying that it's something that they care about. But if it is something that you and your company or you need personally, go to the issues on the GitHub and also go through your normal Microsoft support reps and tell them that this is important, and it'll get on their radar if that's the case. But for now, they're saying that they have no interest in adding it, and it's up to the community, so the community can do it. I looked at the possibility of adding this. There are new APIs in .NET Core available that can do this. And I linked to a blog at the end that I kind of point people in the direction if they're interested in actually doing this work. So it is up for grabs, and anybody in the community is welcome to add an analog for that command. So another kind of pain point about cross-platform anything is that things never work 100% on every platform, no matter how hard you try. macOS is really picky here, and this has something to do with the way that .NET Core implements their HTTP client. Basically, it's a wrapper around libcurl. So if you're familiar with curl on Linux or Mac OS, the libcurl is kind of the backend that curl actually uses, and PowerShell and .NET Core are doing the same thing. They're just wrapping around libcurl on Linux and Mac OS. But Mac OS's libcurl is different. It no longer uses OpenSSL by default. They're using a completely different SSL plugin. And HTTP client was built to work with libcurl plus OpenSSL, so it doesn't play nice with all of the advanced SSL features, which means that some of the new security features that I'll talk about are kind of broken or don't work completely on Mac OS unless you do certain things to make them work. The main thing is that if you're using Mac OS and you're using the web commandlets from PowerShell, you're going to want to make sure that you install libcurl, OpenSSL, and GSS API from brew. If you do it that way, most of the things will be covered. If you don't, you're going to run into a lot of errors that you're not expecting. And this can happen on some of the other Linux distros. CentOS 7 and Red Hat 7 are also not shipping libcurl with OpenSSL by default. But if you install libcurl with OpenSSL on those OSs, all these problems do go away. So the magic word there is OpenSSL. And just if you're seeing any kind of weird issues trying to use some of the new security features, then that's where to look. So SSL 3.0 has been axed. It's not supported by .NET Core. So if you're using any old systems that are still on SSL 3.0, the web commandlets aren't going to work on it. It does support TLS 1.0, 1.1, and 1.2. It does not yet support TLS 1.3 or 2.0, whatever they're wanting to call it at this point. But that's not really in heavy use yet, so I wouldn't worry too much about that. If you still have SSL 3.0 and 2.0 and 1.0 in your environments, you should be looking at HTTPS proxies to stick in front of those as soon as possible. There's no service point manager support in PowerShell Core. The web requests in Windows PowerShell, that .NET API honored things that were set in Service Point Manager. This isn't necessarily documented for PowerShell, although I saw that somebody added to the documentation using the server certificate callback. But I see a lot of scripts out there that make use of these. And in Windows PowerShell 5.1, modifying these would then affect the operation of Invoke-WebRequest, Invoke-RestMethod. HTTP client does not honor these settings at all. So if you have any of this in your code, it's not going to do anything for you. It's going to be completely ignored. So since that's not available, you can't do any kind of custom certificate validation. There are some projects out there that need to be more secure in their code, so they've implemented their own .NET classes that do some validation, and then they plug it into that service point manager, and then they use the PowerShell commandlets to actually do the bulk of their work. So that's not available, so you can't do that. But one thing that we did add that is really nice is skip certificate check. So if you do any work with self-signed certificates, or you're trying to access a site that has expired certificates, things like that. In Windows PowerShell, that was really kind of painful to do. You had to jump through some hoops to make work. But in PowerShell Core, we've added a skip certificate check, and I'll go more in detail in that in the next section, which is all the new features and fixes. So we've added a lot of new features in PowerShell Core 6.0. And I think only 2 of these were actually added by Microsoft. The grand majority were added by either me or a couple of other community members. So that kind of shows you the power of the community in PowerShell Core, and that it's not just Microsoft pretending to be open source. It really is open source. But I wanted to start off by just showing the parameters. I'll go in detail about all of these, but I just wanted to show you so you can just see them all lumped together and see just the numbers here. I mean, allow unencrypted authentication, custom method, no proxy, preserve authorization on redirect, skip certificate checks, skip header validation, SSL protocol, and token. And those are for both Invoke-WebRequest and Invoke-RestMethod that have been added. For Invoke-RestMethod, we've added 3 more additional to those other ones, and that's follow rel link, max follow rel link, and response headers variable. So it's quite a bit of new features that are available. So one of the new things is that we've updated the user agent so that it actually shows you what platform you're on, and it's a little bit smarter. I just wanted to kind of show these real quick. This might have an impact on you if you're doing anything with more traditional websites. So websites tend to look at your user agent and then serve up content that fits your user agent. At least some do. This won't have much impact on APIs, like REST APIs and stuff like that. So, but I did want to just kind of demo them and go over them real quickly. On Windows PowerShell 5.1, this is what you would see pretty much. It's got Mozilla 5.1, Windows NT, Windows PowerShell 5.1. It's kind of standard there. And in 6.0, we've kind of updated it to where, you know, it's got the version in the thing here that's closer to RFC compliance for the user agent, and we've changed it from Windows PowerShell to PowerShell. But on Linux and Mac OS, you know, we've updated it so that they actually show the right things there. In pull request 4914 and 4937, we actually fixed this because in previous to those, in beta version 7, these were still saying Windows. So we fixed them now, and they actually report the right operating systems. So authentication is one of my babies that I got added in. The web commandlets included some authentication, the credentials parameter, if you're familiar with it. But it doesn't work in the way that a lot of people expect. Credentials in Windows PowerShell 5.1 on Invoke-WebRequest and Invoke-RestMethod, when you supplied credential, it would only work if the endpoint did a challenge response type authentication. And that's kind of fallen by the wayside. A lot of modern APIs expect explicit authentication. They expect you to send the username and password when you connect, not to be challenged for it. And so we've added this new authentication feature, which is the dash authentication, or dash auth for short. And we've added support for basic authentication and bearer OAuth authentication. And as I mentioned, this is explicit. When you supply these, it will send the credentials to the server without being challenged first. And then we're looking at possibly adding some more in the future besides basic and bearer and OAuth. And that was added in pull request 5052. And just to go into each of these, the authentication basic is an RFC 7617 authorization basic request header. You use the auth parameter, and it requires the credential parameter, which takes a PS credential object. It does not support use default credentials, so you can't pass through your Windows login username and password using this method. So just down at the bottom, there's a demo of getting the credentials, and then going to a URI that takes a username and password to get in, and then doing Invoke-RestMethod -auth basic -cred credentials -URI and the URI, and you would get the response from the authenticated web page without being challenged. So the next one is authentication bearer. Yes.
Are these values being sent encrypted or unencrypted?
Are they being sent encrypted or unencrypted?
So you can send to encrypted or unencrypted to HTTP or HTTPS, but if you try to do HTTP, it will prompt for it'll error if you try to do HTTP. I have another new parameter that I'll cover here in a little bit that you have to pass in order to send credentials over HTTP.
Okay, thanks.
So the bearer and OAuth, it's basically the same thing. Bearer is the name of the type of authentication, and OAuth is its more common referred to name. So they both do the exact same thing, but they're included just for convenience. They're RFC 6750. They use the auth parameter, and then use either bearer or OAuth for that, and then it requires a token parameter, and that token parameter is a secure string. So down at the bottom there's a demo of it where you do a read host for a secure string to have it prompt for the token, and then go to the URL with -auth OAuth -token URI. So usually when you're dealing with OAuth, you're going to have to request the token, usually with basic authentication first, and then you would have to parse the response, turn that into a secure string, and then use it to the token. The reason why we're requiring token to be a secure string instead of a string is that, well, OAuth is supposed to be a temporary secret. I've run into plenty of APIs where their OAuth do not expire for 6 months. So that makes it closer to a password than a temporary token. So I didn't want people putting their tokens in plain text in their scripts as much as possible. So this kind of discourages that behavior. So going back to what was asked, sorry?
Do you have any plans to switch from OAuth 1 to OAuth 2, or is it for OAuth 2?
So this is just the bearer header. It doesn't actually manage OAuth lifecycle, so the actual OAuth RFC is irrelevant for the exception of the bearer header to what's being done here. So both 1 and 2 use the bearer header. It's just 1 and 2 differ on what you actually put in the token when you're requesting and responding.
Okay, thanks.
No problem. So yeah, this the OAuth parameter that I did will work for both. So going back, what was asked about encrypted, this is what I was talking about here. If you try to send the credential objects, and this includes the old just credential by itself as well. We've added that as well. But auth basic or auth OAuth or auth bearer, any of those, if you try to send those over an HTTP site, you're going to get this lovely error message about the commandlet cannot protect plain text secrets over unencrypted connections, blah, blah, blah. And at the end, there's a bit there about specifying the allow unencrypted authentication parameter. So we've added that in, so you can kind of see here how to do that. If you really need to send credentials over HTTP, then you can bypass this. But you really should be using HTTPS. If you have HTTP, let's say you have a device and it only supports HTTP and it's internal, you should look at putting that behind some SSL reverse proxies for you. That would be the best way to handle it, especially if it's taking any kind of secrets and logins. You really shouldn't be using HTTP, and if you're deploying HTTP, you should probably investigate your practices and look at making sure you're always deploying HTTPS. But it's there, and we know that you can't get away from it. So we've made this available to at least kind of prevent you from sending your secrets over HTTP as much as possible. And all this work was done in pull requests 5052 and 5402. So remember I was saying that the headers are in an array now, and the reason for that is that APIs and stuff will send responses like this sometimes. They'll have X header and they'll have X header on 2 different lines. And in Windows PowerShell 5.1 and older, the WebRequest API would just mash value 1 and value 2 together with a comma between them. So you wouldn't know if they came in as separate headers. HTTP client allows the support of multiple headers in that array. So value 1 would be element 0 and value 2 would be element 1 in the X-headers portion of the header collection. So that means that, like I said before, the headers is now an array. And also, because this is done properly by HTTP client, the raw content, that's property that's returned from Invoke-WebRequest, we now properly show the headers, because this is actually reconstituted from the headers object when we're displaying the raw content. And since Windows PowerShell was kind of mashing those together with commas, you weren't actually seeing a proper representation of what was being returned from the server. Now you do. And this was done in pull request 4494. Basic HTML response object headers performance has been enhanced significantly. In Windows PowerShell, that headers property returned from Invoke-WebRequest, that was every time you accessed it, it was generating a fresh hash table. So that was kind of ridiculous. Lots of memory bloat and that. And there was a lot of operations where you would need to access it and then do some work and then access it again and all of that. So what we've done is we've gone in and we've changed that now, where it doesn't generate it until the first time you access it, and then after you've accessed it once, you get the same headers collection back every single time. So it's faster and it's less memory overhead if you were doing a lot of header operations. And that was done in pull request 4853. So response headers are important for a lot of APIs. Very important on some. Some it's just kind of silly stuff that they send back. But for example, I'm accessing the Reddit API, and it returns X rate limits related headers to tell you where you're at in your rate limiting, to see if you've made too many requests to their API. And that's kind of critical to watch, because if you abuse their API, they will not only like stop your bot from accessing it, they'll kill your user accounts. So you kind of need to watch those, and those objects being returned from the APIs are generally like JSON and XML, and Invoke-RestMethod is great for those because it takes that response and turns it into an object that you can use in PowerShell. But if you need to watch the response headers, in Windows PowerShell, there's no way to do that with Invoke-RestMethod. The response headers are unavailable to you. So we've added the response headers variable parameter on Invoke-RestMethod, and that will basically return the same kind of headers collection that you see on Invoke-WebRequest. And it works kind of like the session variable parameter, where you supplied a string and it creates a variable in your calling scope with that string name, and then populates it with that collection. And this is only available on Invoke-RestMethod because you already get the headers collection on Invoke-WebRequest. And that was done in pull request 488. And just to kind of show how that works, just going to http bin.org get, supplying response headers variable RHV, and then it creates the RHV variable in your scope, and when you look at it, you'll see a nice key value pair of all the response headers that were returned from the API. So that could be very useful for that. In Windows PowerShell 5.1, if you needed to do the same thing, you would have to fall back to Invoke-WebRequest, make your call, then look at the content of the response object and parse the content type to see whether it's JSON or XML, and then take your content and then convert it to an XML or JSON. It's a lot of work just to see the headers. So we've kind of simplified this by allowing you to see the headers a lot quicker. SSL protocol, this was added right before RC1 release. This is the last new feature in 6.0 that was added because all the RC stuff is just critical fixes before we go to GA release. So this was the very last thing put in. Basically allows you to select the TLS version that you're going to use. So you can limit it. So some security requirements require that all communications only be done over 1.1 or 1.2 because 1.0 is not as secure anymore. 1.1 is falling off that list as well, and 1.2 is considered secure now. So if you're doing a lot of regulatory work that has to fall under this kind of stuff, there was no way really to do this without using that service manager API I was talking about before in Windows PowerShell. So we added this in PowerShell Core 6.0, so you can set these, and you just kind of set the you do SSL protocol and you tell it either TLS, TLS1, TLS12, and this uses the a flags enumerator, which is kind of weird for PowerShell, but the reason for that is because it's kind of mimicking the same protocol that's used in .NET for a lot of other stuff. So this is what it looks like when you're using it. Just going to google.com is a good example to do. So if I want to just make sure that I'm only doing TLS12, I can supply SSL protocol TLS12. If I want to do TLS12 and 11, I'd supply them both that way. Now notice, this isn't a typo. This is really how it is. It's a single string with a comma and a space. And that's because it's a flags enumerator instead of an array or an array of enums. So that's a little odd for PowerShell, but as I said, you run into situations where you have to use that same enumerator in multiple pieces of code, so we chose to go with this to kind of alleviate that. Most people are only going to choose one anyways, so it's not going to be as big of a deal, I don't think. So the custom method parameter that we've added, there's a lot of APIs, especially for IoT devices, that want custom verbs to be sent to them. So you have your standard verbs like get, post, put, delete, and those are supported by default with the method parameter in PowerShell. But these newer IoT devices have weird verbs, like a fictional water purifier here might have a purify command that you need to send to a to the endpoint to make it actually start the purify process. I've seen some pretty weird ones out there, but the Windows PowerShell commandlets wouldn't let you do that. You only could use those default methods. So we've added a custom method parameter in PowerShell Core 6.0 that allows you to send whatever you want to, and that's kind of a demo there of something to purify commandlet to an endpoint and just kind of seeing that it comes back and says that it was purified. And that was done in pull request 3142. So no proxy has been added. This allows you to bypass the system proxy that is set in Internet Explorer. And then in Linux and Mac OS, there's an environment variable, I think, that .NET uses by default. So the default action is that PowerShell uses your system proxy, or it uses the proxy that you supplied to the proxy parameter. But there are times when you need to make sure you're not using the system proxy, and this allows you to bypass it. So you just supply the no proxy and it bypasses it. You might think that that's a security flaw, but in reality, the system proxy was never meant on Windows to be something that could be forced through all APIs used in Windows. So it's not really. And you have a lot of programs on your system that will just ignore whatever proxy you've sent. So normally if you need to enforce proxy on anything anyways, you do it at the network level by not allowing HTTP to talk to anything other than your proxy. So that's normally how you deal with it, not try to rely on GPOs or anything like that. So preserve authorization on redirect. It's too large for that line, but this allows you to send authorization headers when you're redirected. Some APIs, you send your login request to a general login endpoint. It parses like maybe the username to determine what actual authentication server you need to be sent to, and sends you a redirect request. And then you would go. In Windows PowerShell 5.1, there was no way to actually pass through to that. So you'd have to make two calls. You'd have to make the first call, look at the response with max redirect 0 so that you could make it stop, come back, look at the response, take that response, and then make another request to the next endpoint. Hopefully there aren't too many APIs doing this, although the Office 365 WinRM is actually doing this. So it's kind of a bad design. You're not supposed to do it, but plenty of them do it. So this allows you to send your authorization headers and allows them to pass through when redirect's done. So this is kind of insecure. I wouldn't set this on by default, and it's kind of a good thing that this is a really long and ugly parameter, so hopefully people don't use it often. But if you need to, it's there. Skip certificate check parameter. This is a feature that was really desired by a lot of people in the community. This was added very early in PowerShell's open sourcing. I think that people jumped at the chance to get this added in as soon as possible. But skip certificate check allows you to bypass any kind of certificate. So any HTTP site you go to, it just looks at the certificate and says, that's fine. I don't care if you're expired, that I don't trust your CA, I don't, that you've got malformed stuff in there, whatever, your certificate's fine. That's good for a lot of testing because a lot of test suites use like self-signed certificates to do a lot of work. So this was kind of sorely needed. And that was added in pull request 2006. Link header pagination, this is my favorite feature that was added. It's not one that I added myself. So this one was actually added by one of the PowerShell guys. So this is the Windows PowerShell team guys. So this is one of the few features to the web commands that they actually did do, but I think it's absolutely awesome. On Invoke-RestMethod, you can supply the follow rel link parameter, and this will allow you to follow the next links that are returned in RFC 5998 headers. So an API will return a link header, and it'll have a link with the next object in the page. So like, let's say you're accessing the GitHub issues, for example, and you go to the first page, and it's 20 per page, and there's 1,000 issues. So that's whatever 50 pages, right? Or 500 pages, whatever it is. Math's not good right now. You need to follow the links that it gives you in the response headers to know what the next page is. So we've added this in. There's two parameters to it: follow rel link and max follow rel link. follow row length turns the feature on, and max follow row length sets the maximum number of pages that you grab. So this is only added on Invoke-RestMethod, but on Invoke-WebRequest, we are taking those link headers and we're putting them in a relation link property on that. These were added in pull request 3828, and there was a fix in 5265. So as just a demo of this, as I was talking about with the GitHub issues, this is pulling in the PowerShell repos issues, open issues. And it returns 30 issues per page. So what I want to do is I just want to grab 2 pages worth of results and look to see how many results are in each page. So I supply maximum follow rel length 2, so I'm only going to grab 2 pages. And I use the follow rel link parameter, and I make the Invoke-RestMethod request. Invoke-RestMethod goes out, grabs page 1, and then it goes and grabs page 2, and it returns the objects from both. And when you count them, you'll see that there's 30 objects in each page. So this will help a lot with a lot of paginated requests that are out there. And a lot of APIs are using this. So on the Invoke-WebRequest side of it, you can look at the relation link property, and you can see that it returns a key value pair of the relation link. So you can see that I grabbed page 2, and it provided a next link of page 3. It provided a last page of 39, and the first page of page 1 and the previous page of page 1. So if you're using Invoke-WebRequest, then you can kind of look at this stuff too to continue your pagination quest. Multi-part form data support has been added. So Windows PowerShell 5.1 had no way to do multi-part form data support at all with Invoke-WebRequest and Invoke-RestMethod. If you needed to do this kind of submission, you had to use .NET APIs directly to do it, which is really painful. Now, this current implementation is still a little painful, but at least you can use the web commandlets to do it. And this isn't its final form. So I'm going to show a demo on the next page, but basically you supply a multi-part form data content object to the body parameter on Invoke-WebRequest or Invoke-RestMethod, and it'll make the request for you. This was added in pull request 4782. And you see from this example, just it's complicated. The way that you do it is that you use these content disposition header values, set a form data, create a string content value, and then you add that to a multi-part form data content, and then you set that as the body. Pretty complicated right now. But we needed to get the groundwork in because we're adding a simplified version of this in 6.1. So my first feature that I'm putting in for 6.1 is going to be this. What it'll do is it'll take a form parameter, and that form parameter will be a hash table. And if you supply a string value for one of the values in that, it'll be a string content. And if you supply a like if you get child item or get item on a file, it will take that file and upload that file. So don't have a demo of that because right now it's only mocked out in my head. I have a mock-up demo on the in-depth blog post, but just know that this is complex right now, but it's just so that we can get the underlying architecture in place for better implementation later. So one of the final fixes that I got in to this was that Invoke-RestMethod now properly handles null JSON literals. So JSON, generally people are used to JSON being either a JSON object or a JSON array, but JSON can support a string or an int or null or true or false by themselves without any kind of object or array formatting to them. And those are totally valid JSON, but Invoke-RestMethod in Windows PowerShell 5.1 was treating a null JSON literal by itself as the string null. So instead of going to an endpoint that was returning null, which should in PowerShell be $null, it was returning the string null. So we fixed that in pull request 5338. And this is kind of just a demo of what I'm talking about here. This endpoint would return null all by itself. Windows PowerShell 5.1 doesn't see that as null, it sees it as a string null, whereas PowerShell Core sees it as null and not the string null. So that's it for the new features. So some of the things that we're planning for the future are some custom certificate validation. So like I said, since that API doesn't work anymore, the service point manager, we need to add in the ability to do certificate validation. I had a work in progress PR for this, but it went through several review cycles from the PowerShell committee, and it's been changed multiple times, and I need to go back and revisit it. So I've pulled that pull request off of there, and I'll be revisiting that after I get multi-part form data back in. So that's planned. We're going to look at adding some better session and process level settings, kind of expanding that out so that the session variable is a little bit more useful than it is now. And then also look at session level settings. So the ability to set strict things such as the TLS version that you're going to use, and make sure that even modules that try to circumvent that will be forced into compliance. So the idea there is that you need some forced compliance. You need to ensure code is doing the right thing, and you'd be able to do that at the PowerShell session level, or process level rather. So you start PowerShell, you set some settings, and then those will apply to everything in PowerShell, in Invoke-WebRequest and Invoke-RestMethod. Again, the better multi-part form data support using the form parameter is going to be coming in. FTP support, that's going to be added in. And we're also looking at stream support. So there's a technology like log streams where you make a request to a page, and it continually returns results. It doesn't stop until you stop requesting. So that's called a stream or a web stream. And people are more familiar with this, like streaming video and things like that, but there's a lot of other technologies that do it too. So we want to be able to add some of that support in PowerShell, but we need new commandlets to do it because they need to be stream-centric. They need things like maximum bytes, max lines, and those don't make any sense whatsoever to put on Invoke-WebRequest and Invoke-RestMethod. So we're looking at adding that as well. So I have all of these slides on my GitHub. So my username pretty much everywhere is Mark E. Kraus. You can find me on Twitter, on GitHub there. But this slide presentation is there. If you go to getpowershellblog.blogspot.com, you'll see I have a 3-part blog series that starts at the end of November that is goes even deeper in depth on all the stuff that I've covered here and more things that just wouldn't fit into this time frame. So if you have some more questions, I guarantee you most of them are going to be answered in that blog as well. So that's that, and that's the slides. Yep.
Put your contact information back up there for just a moment.
Sure.
All right, I got it. Thank you.
I did have one last question.
Sure.
Between the two platforms with 5.1 and 6.00, there are quite a few Azure commandlets that are out there that do whatever they need to make contact with the Azure platform and do various things. Is there a portability potential problem between maybe those two platforms, or am I comparing apples to oranges?
So there are some issues. Azure commandlets, if you look on the PowerShell gallery, you'll see that Azure now has some Azure Core commandlets, and that's because the Azure commandlets on Windows PowerShell rely on an authentication mechanism that allows you to do browser-based authentication, which hooks into some GUI elements, which are obviously not in PowerShell Core because there is no GUI on a headless Linux box. So that's kind of why that those haven't all been completely ported over. But that's really the Azure's team. The good news is that Azure just put out that CLI, that even better CLI for cross-platform. So while they're working on getting everything working in PowerShell natively, you'll still be able to call out to that command line interface that they've provided. Not ideal, but it'll work in the meantime. But they are aware of this. So the way Microsoft is structured, the PowerShell team that's actually making PowerShell Core doesn't make a lot of the things that people think of as PowerShell, like the Active Directory module and the Azure module. Those are made by the Azure team and the Active Directory team. Those are not made by the PowerShell guys. So these product teams and OS teams that control a lot of these other modules, they won't be making a lot of their core modules available until PowerShell Core is actually released. So some of this stuff is kind of behind the curve, but Windows PowerShell isn't going away. 6.0 is never going to replace 5.1 as far as 5.1 is. 5.1 will eventually die off because they're not going to add any new features to it. They're only going to be doing critical bug fixes and security issues. That's it. So all the new features that I've talked about here, those are only going to be in 6. Those are only ever going to be in 6. So people are going to start moving to 6, and the product teams and OS teams are going to start making modules for PowerShell Core. That's not really going to come until a little bit later. So there's a lot out there now, and a lot of vendors and third party have already released their core versions of their modules. So it's getting there, but you're going to run into a lot of differences between the two because it is a major version, and it's a true major version update to the language. A lot of the base language things are normal, so plus still works the same way, equals still works the same way, using a pipeline still works the same way, but a lot of the commandlets, there's more new commandlets, there's a lot of missing commandlets, there's a lot of new parameters, a lot of parameters have been removed, there's been a lot of breaking changes. So a lot of the modules that you're used to on Windows PowerShell, even when they get ported over to Core, you might not be able to use some of your same code that you've used in Windows PowerShell. So you might have to make some adjustments.
Hey, Mark.
Mm-hmm.
So running, installing 6.0 Core, do you just recommend just throwing it on your laptop or whatever and run it concurrently with 5.1?
Yep. Yeah. So you can go and download the MSI, or if you're using Linux, you can use Yum or apt or whatever package manager, and then on Linux, on Mac OS, you can use Brew to install it. And yes, it does install parallel. It does not replace 5.1. You can call Windows PowerShell from within PowerShell Core. So PowerShell Core's binary is PWSH instead of PowerShell. So if you want to start PowerShell Core, you start PWSH. If you want to start Windows PowerShell, you start PowerShell. And inside PowerShell, Windows PowerShell, if you want to call PowerShell Core, you just do PWSH and then whatever PowerShell commands that you normally call out to PowerShell for. And then you can do the same thing from PowerShell Core. Call PowerShell.exe and call whatever else. So you can kind of call back and forth that way. And you can also use PowerShell remoting. You can remote from 6.0 to Windows PowerShell 5.1 and vice versa. You can remote from a Windows PowerShell 5.1 into a PowerShell Core 6.0. So you can do that on your own system. So there's a lot of different ways to interact with both of them too and run side by side. And you can also, if you want to, download or do get to pull in the repo and build it. It builds using Windows PowerShell. It's pretty easy to build. There's like 3 commands to build it on Windows. So if you want to build the latest, greatest version of it, you can do that. So you can run multiple versions of 6 at the same time. You can run the latest 6.1 preview alongside 6.00 and 5.1 all at the same time.
So does the 6.0 come with an ISE?
It does not. So, and ISE is not going to be made to work with PowerShell Core. All the work for an IDE for PowerShell is being focused into VS Code, which works with both Windows PowerShell and PowerShell Core, and you can switch back and forth in the PowerShell extension in VS Code. It has its pluses and minuses over ISE, but a lot of the same features are there, and more of the desirable ISE features are being added to the VS Code PowerShell extension all the time. So that's where Microsoft is focusing their attention. But
so
they've said,
can you access it via 6.00 via Visual Studio?
Yes, but I haven't tried it myself. I only know from what others have said that it's possible. And in ISE, you could start ISE and then run PWSH, but you're not going to be able to get like debugging and all of that working and command completion that works in the editing pane. So you can still run PowerShell Core in ISE, but you won't get all the features of it.
But it's doing good at Visual Studio Code.
Oh, absolutely. And a lot of us, I switched to VS Code for development work. I still use ISE as my console because I find it's a little bit better for console use. Because I do a lot of stuff where like I mock out the code and then I F8 it to run it. I don't really like that piece for VS Code, but like for the actual like development features of actually like writing modules and scripts, I love it for VS Code and prefer it over ISE.
Yeah.
The VS Code itself comes with a lot of features absent PowerShell that just make it a much richer and easier to use editor. So that's what it's got going for it over ISE.
Single pane of glass.
What versions of Windows will 6.00 run on?
So it'll run on Windows 7 and up, and whatever version of server that matches with. Is that 2008? I can't remember. So it runs on pretty much everything except XP 2003 and older. So it does run on Windows 7. I've used it on Windows 7, and they did finally release a x86 version of it, so it will run on the x86 versions. It's also will work on Nano, and it works on Nano Server, and works in 2016, so it works in the newer operating systems, obviously. And they currently don't have plans to include PowerShell Core with Windows, so it's not going to be a Windows feature in the immediate future. And they're also not going to be providing updates through Windows Update or anything like that. So PowerShell Core, you might think of it as like almost a third-party app or another Microsoft app.
All right.
Thank you.
Hey, Mark, this was awesome, man. You know, you kind of inspired me because, like you said, you're putting your input into PowerShell, and it's truly a community application now. So very cool. Like I said, I like to maybe take something with the Git community and learn some other how to do some of those issues and, you know, do some of those things. That sounds like our next step, just to get used to the GitHub community.
Yeah, it's great. The whole community aspect of this, a lot of people kind of mocked Microsoft when they started going to open source, thought that they wouldn't take it seriously, but PowerShell has definitely proven that, at least with this project, they're committed to the community. They added the first community maintainer, Ilya. So somebody who doesn't work for Microsoft has the permissions to merge code into PowerShell. Think about that. And they take direct feedback from us in the GitHub repo all the time. They're accessible now. They're not hidden behind a user voice thing. We know their names. They have some accountability now as a result of that as well. And I just met Travis Plonk from the PowerShell team over the holiday break, and we were discussing this as well, that just how awesome it is that the community can be involved in this.
Yeah. I've just one question. As kind of the organizer for the PowerShell group, wanted to know if you had access to any information on any type of PowerShell conventions or any organizations that might be out there, you know, doing any of these conferences where we can, you know, definitely send people or, you know, anything of that nature.
So the big one that's coming up is the PowerShell Summit. That's a big one that's put on by Don Jones and the PowerShell.org team. That is a huge one. That's like pretty much the big one for US anyways for PowerShell. There's quite a few that go on in EU. There's the PSConf EU, and then there's the was it APAC PowerShell, but they're going on all the time. The best way to find those out, though, is to kind of plug into either the PowerShell subreddit on reddit.com or to look at PowerShell.org. Those get posted there quite a bit. And if you follow me on Twitter and you kind of look at some of the other Microsoft MVPs for PowerShell, they are constantly posting. I mean, there's more PowerShell conferences than are available. I'm kind of new to these. I haven't actually been to any. I'm going to my first one for this PowerShell conference, the PowerShell Summit. So it's kind of new to me as well.
We're going to invite you to our IT Pro Camp in June. We'll definitely have a PowerShell track, and hopefully we can get you out of Texas. Yeah.
All right.
Yeah, more to come on that. All right, anybody else got any questions? Mark, this was awesome, man. Like I said, you've inspired us to take a look into PowerShell a little bit deeper and find out what we can contribute to this awesome application. So, thanks for putting this together for us.
All right, and thanks for having me.
Have a good evening. Thanks so much.
You too.